0.681 times 10 to the power 6 Pascal. Let me do it again. So 0.259 divided by 2 minus 0.01. That's by 16 power 3 divided by 40.1 power minus 6. 47681. Okay. So we found our best x. Okay. So I think the more important thing, I'm going to introduce another step. Okay, because it will help us a lot later on. So we know that this is equal to what? 16 times 10 to the power 3. And then we have 0.259 divided by 2 minus 0.01 divided by 40.1 power minus 6. So that value is 2.98 times 10 to the power 3. So then times by 16 power 3. Yep. Okay. So this value is important because later on for the other position, we no need to always calculate. Okay. So next we calculate the shear. So the shear XY is equal to what? So it's equal to the shear force. The V is equal to what? 80 times 10 to the power 3. Okay. So we know that is Vy over Izz Qz divided by T. Okay. So again, is this position we want? So Vy is a straightforward part. Okay. So Vy is equal to what? 80 times 10 to the power 3. The Izz is given over here, which is a blessing, 40.1 times 10 to the power minus 6. The thickness is the thickness of the what? Thickness of the web. So thickness of the web is what? 6.35 times 10 to the power minus 3. And then the QZ, the width is your BF, 0.102. The depth is your TF. TF is 0.01. And then the Y bar is D divided by 2, 0.291. So 0.259 divided by 2 minus by TF, 0.01 divided by 2. So this will be equal to, again, 80 times 10 to the power 3, bracket 0.259 divided by 2 minus 0.01 divided by 2 times by 0.01 times by 0.102. I got 126.99 times 10 to the power minus 6, and then divide by 40.1 times 10 to the power minus 6. 6.35 times 10 to the power minus 3. Okay. Let me do it again. 0.259 divided by 2 minus 0.01 divided by 2 times by 0.01 times by 0.102, 126.99. So this will be equal to 80 times 10 to the power 3 multiplied by 126.99 power minus 6 divided by 40.1 divided by minus 6 divided by 6.35 power minus 3. 498.714. And this will be times by 80 power 3 is equal to 39.897 times 10 to the power 6 Pascal. Okay. Let me do it again. Okay, so 80 power 3 times by 498.714, 38.897. Okay. Okay, so we have all these values now. Okay. So I'm just going to put everything together. Okay. So we know that when X, right? So we know that when X, bear with me, okay? So we know that when X is equal to 0.8. We know that normal stress X is equal to 47.681. Okay, so stress X 47.681 times 10 to the power 6 Pascal, 47.681. And then we know the shear XY will be equal to what? The shear XY will be equal to 39.897. Okay, so 39. Now, if we were to do X is equal to what? 2.4 meters. Right? So if X is equal to 2.4, right? So at 2.4, our moment is equal to 48 times 10 to the power 3. So we have 48 times 10 to the power 3. And then we just need to multiply the coefficient, which is 2.98 times 10 to the power 3. This is equal to 2.98 times 10 to the power 3. So 48 times by 2.98 power 3 is equal to 143 point what? 04 times 10 to the power 6 Pascal. And then the shear XY at this point, right? The shear XY is equal to what? So at point, the shear is equal to 0. Okay, so this one is the shear is equal to 0 Pascal. And then when X is equal to 3.2, that's why calculate the coefficient really help, yes or no? Your stress X now becomes what? It becomes 32 times 10 to the power 3 multiplied by your coefficient. So 32. So this is 95.36 times 10 to the power 6 Pascal. Okay. And then your shear XY will be equal to what? So the shear will be equal to what? 40. Okay, so 40 times 10 to the power 3. Multiplied by the shear coefficient, which is equal to what? 498.714. 498. So 40 power 3 multiplied 498.714. So it's 19.948. Right? So we know for this case, right? Because the shear is equal to what? The shear is equal to 0. Yes or no? So when the shear is equal to 0, right? We know that at X is equal to 2.4, right? It is what? So this is at the principal what? It's at the principal plane. Because your shear stress is equal to 0. So therefore, stress max for X is equal to 2.4 is equal to 143.04 megapascal. Now we don't know at 0.8 and 3.2. Okay, we don't know what is at its principal plane yet. Okay, so now if we were to move the 3D element across, okay, so now we're going to move the 3D element across. Remember, everything we do now is 3D, yeah? It's the real world. So if now we were to sketch 3D mole circle, okay, the purpose of sketching the 3D mole circle is to find, so I'm going to write down here, we have to sketch the 3D mole circle to determine the plane where tau max occur. Okay. To put in simple terms, where the largest diameter occur. Okay. Where the largest diameter occur. I know it doesn't look good now, don't really understand what I mean. It's okay. I will do it for you. Okay, I want to show you what this actually means. So if we're going to sketch 3D mole circle, this is your point X, this is your point Y, and this is your what? Your point Z. Yes or no? Right? So that's X, Y, and Z. So I'm going to sketch this out. So again, this is just a sketch, right? So this is your normal stress, okay? So when what we calculate, we're going to assume that normal stress is in this direction. Stress X is positive, okay? So this is our shear. So we are going to sketch our normal stress. So we know that this is our normal stress, our normal stretch, our normal stress line. So this is our stress X. We know that our stress Y and stress Z is on the vertical where this is equal to 0. Element rotate clockwise, element rotate anti-clockwise, and then we will sketch our shear. So at point X, element rotate clockwise. This is our point X. Okay, over here, this is our point X. Over here, this is our point Y. And point Z, everything has 0. So when we sketch this out, okay, so we know that this is our what? XY plane. And our XY plane, as you can see down here, this is our what? In plane. It's our in plane because it has the largest surface area. And then we can draw a line across. And then the next line that the next circle that we can sketch is a smaller circle. Okay, and this circle over here belongs to our YZ plane. And the last circle that I'm going to sketch okay, this circle belongs to our what? Belongs to our XZ plane. So we found that tau max, we have to declare this, okay? So we have to declare that tau max occurs in the what? In the XY plane. Okay. And this is true, okay, this is true where x is equal to 0.8 meters and where